making it highly resilient. So look at blockchain as the infrastructure that is powering smart contracts. So we have some of the features whereby we have some of the features of a blockchain. Number one, it is immutable, it is distributed, it is transparent, and it is very, very secure. Why do we say it is immutable? It is immutable because the moment a contract or the moment something a smart contract is being deployed, data cannot be altered. Nobody can actually alter anything that is deployed on a blockchain. Now it is distributed, meaning copies are held by all parties. It is distributed. Blockchain technology uses what we call distributed computing. So it means it is not in a centralized location, or it is not controlled by a centralized entity whereby you feel like you just go there and then alter whatever you feel like you want to alter and then make it known. No, blockchain is actually distributed, meaning whatever is in block A is the same thing that is in block B. Nothing that is altered, nothing that is being deployed is going to be of different copies. All of them are going to be the same. Also, smart blockchain is what is transparent. All transactions are publicly viewable. That is why when someone said, I've sent you something into your wallet, you can verify that without you trying to argue with that person whether it is true or not. By what? By just going to what we call explorers or block scanners. Explorers can actually tell you when this transaction take place, or whether it has taken place or not. So it's very transparent. It is publicly viewable by anyone that is trying to be, or that is trying to use this technology. Also, blockchain is very, very secure. It is protected by what we call cryptography. So cryptography is a form of mathematical calculation that needs to be carried out before anything that needs to be carried out on a blockchain to make it more secure. So no one can actually go and feel like, okay, it's just some files that have been stored on a particular database. That's how it is. No, that's not how it is. On a blockchain, it's a very different case. So that is for blockchain. So how does this blockchain work? How does it actually work? So to give you a simple analogy, let me just read directly from the slide. Transactions on a blockchain are grouped into blocks. So block, the collection of those blocks are called what? Being chained together, we call them blockchain. Each block is then linked to the previous one using a cryptographic hash. This is a form of what? This is a form of encryption, forming a secure and unchangeable chain. This process ensures the integrity and chronological order of all data. New blocks are added through a consensus mechanism. There's what we call consensus mechanism. Each blockchain has its own consensus mechanism. So it says such as proof of work or proof of stake, requiring network participants to agree on the validity of new transaction before they are permanently recorded. I don't want to bore you with much English, but there's what we call consensus mechanism, proof of work, and then proof of stake. These are consensus that that different independent blockchain carry out before any new transaction is being permanently recorded. So now let's look at smart contract. We now understand that the main infrastructure that is powering smart contracts is what? Is the blockchain. So smart contract is the backbone of Web3. How do we come to that conclusion? Let's look at it. What is a smart contract? The first thing you need to ask yourself is, what is this smart contract? How does it power, or how is it how is it the backbone of Web3? So a smart contract is a self-executing agreement with the terms of the agreement directly written into lines of code. It runs on the blockchain. Do you now see how we mean that the blockchain is the main infrastructure powering smart contracts, automatically executing when predefined conditions are met? So the key take home here, the key point here is a smart contract is self-executing, it removes intermediaries, and it is written in what? In lines of code. So if a particular condition is not met, there is no way a contract is going to run. All right. How does it work? First of all, it is written in code. Smart contracts are programs written in specialized languages. They are not written in normal programming languages like we know, such as JavaScript, Python, and the rest. There's a language for smart contracts. This includes Solidity, Rust. There are so many languages out there defining the terms of an agreement. So after you write these lines of code, you what? You deploy them on what? On a blockchain. Blockchain is a key factor because it is the main infrastructure powering these smart contracts. So when it has been deployed on a blockchain, once coded, they are deployed onto a blockchain network, such as Ethereum, making there are so many blockchain protocols we have out there. We have Ethereum, we have Near Protocol, we have Solana. There are so many of them, making them immutable and publicly accessible. So you need to deploy them on a particular chain or in a particular network before it is widely or globally accessible. How does it work? It is triggered by transaction. They lie dominant until specific conditions, usually involving a crypto transaction or external data, are met to activate them. So if you write a smart contract and you deploy it on a blockchain, and nobody interacts with it, it's going to be dormant there. Nothing is going to work. But the moment you have people, interacting with it, it is going to what? It is going to activate them. So that's how it works. So, and then it is executed by all nodes. Now, those blocks we talked about earlier, they are called what? They are called nodes. Upon activation, all network nodes verify and execute the contract, ensuring decentralized validation and trust. So the whole idea of Web3 is what? Is to talk about what? Decentralization. Everybody has the power, everybody has the power. So how does it work? It's as a result of what? Oh, being distributed across all nodes. All your data or all whatever you deploy on a blockchain is being distributed across different nodes. So that gives you what? That gives you the power, and you ensure that this ensures what? Trust. Because something no one knows where it actually, which node actually contains a particular data, no one has access to it. So it's just like you having a wallet and you don't have the, what do you call it, your passphrase. Nobody will actually tell you how to move, or nobody's going to help you. It's not something you forget the password and you say, I forgot password, I want to change it. No. In this case, it is executed by all nodes. All nodes need to come together before and verifying that yes, this is the person before any kind of transaction can be activated. It is immutable and transparent. The execution and result are permanently recorded on the blockchain, meaning they cannot be altered and are verifiable by anyone. You can verify all these things. We talk about transparency. On blockchains, we have the power to verify whether a particular transaction has been carried out or not. When you have, let me say you are interacting with anyone and you say, please send me this token, the person might lie and say, I've already sent it. It is not like Nigerian banks where someone will say, I've sent you the money and you'll be waiting for hours before you see it. On a blockchain, it is not like that. The moment you send something, in the blink of an eye, it is already what? It is already visible on the other person's end. So it powers what we call peer-to-peer what? Interaction or transaction. So that is how smart contract works. So let's see a real life analogy of how a smart contract works. First of all, it's just like for example, let's use a vending machine. So you input your money, the route you are actually selecting. Then you now give the person the route you are actually selecting, then it will now give output the product you want. It does not require any human intervention. Likewise, a bus ticketing system. When you pay online and you receive a digital ticket, you receive a digital ticket instantly. The condition there is that the payment are already met, and then you receive your what? You receive your ticket. I hope you are all following. Is there anything that is confusing so far? Hello.
Yes, we're following well. I think
Yeah,
everybody.
feeling well, but your skin.
We're
I didn't get you.
feeling
You said
well.
what? All right. Thank you. Let's continue. All right. So why are smart contracts the
Sorry,
backbone
sir.
of? Okay.
Sorry, sir. Please, can you like reduce your pace? You're being too fast. It's hard to catch up.
Oh, sorry for that. But are you clear
Thank you.
with the previous slides, or should I go back?
Yes. No, you could just brush through, sir.
All right. So, looking at how smart contract works, first, before when we talk about smart contract, we are talking about codes that we deploy on a blockchain. Python, and you deploy it on Ethereum or on Near or on Solana. No, you have to use a form of you know specialized programming language. The example includes Solidity. We have Rust. There are so many smart contract programming languages out there. So it defines the terms and condition of an agreement directly. It is a smart contract. So it's directly a smart contract is what is a self-executing code deployed on a blockchain. So whenever the contract, the terms and conditions are met, it automatically run by itself. It does not require human intervention. So after writing the code, the next thing you do, you deploy it on a blockchain. Once coded, they are deployed onto a blockchain network such as Ethereum, Near, Solana. There are so many blockchains out there. So anyone you feel like you can just write it in their languages and then you deploy them on them. You deploy it on them. So smart contracts are triggered by transaction. When you deploy a smart contract onto a blockchain, there is no way it will work or there's no way it will be activated until when it is being triggered by transaction. Transaction is all about trying to access this smart contract by you trying to ensure that you test it or maybe you input some key values. If it is met, it will work. If it doesn't meet those conditions, it's not going to work. And it is executed by all nodes. And lastly, I said it is immutable and transparent. Immutable means you cannot change it. And then transparent means it is viewable by anyone. So I gave a real life analogy of smart contracts. It includes vending machine, for example. The moment you input your money, the rules are already there. Whatever you select, if let me say you want to buy Coca-Cola, if you input, let me say Coca-Cola is 300 or 400, and you input 300, or let me say 250, the moment you are able to select Coca-Cola, automatically it will tell you the condition is not met. But if you impute something that is of that amount and you choose that item, it meets that condition, that criteria, that means it's going to output that product. It does not require what we call it, human intervention. So smart contracts are designed to eliminate, let me just put it this way, to reduce human intervention. Likewise, in the post ticketing system, likewise in what we call escrow account. Funds are held securely until specified conditions are met. So let's go to the next slide. Why are smart contracts the backbone of Web3? Now, when we talk about smart contracts, we talk about these lines that we say we've already deployed or we deploy on the blockchain. Smart contracts are essential for Web3, enabling a new generation of internet applications that are decentralized, transparent, and user-centric. First of all, why is a smart contract the backbone of Web3? Number one, it enables new technology. The technologies that we've not used, previously, the traditional technology we've been using. For example, it powers decentralized finance, non-fungible tokens,
Sorry,
decentralized
sir. I don't know if
autonomous
you can hear me.
organizations. Yeah, I can hear you.
Yes, your slides has not been moving. Is it supposed to move?
Can you see it now?
Yeah, we can see it, but it's not moving. We've been on one page for a while now.
Oh, sorry. Maybe I think it's right. What about now?
Yes, yes, it's moved.
Why smart contracts are the backbone of Web3? Are you all there?
Yeah, yeah, we can see it.
All right. Thank you very much. So, smart contracts are essential for Web3. They power new technology. So previously, let me say 2 decades ago, we don't know what is called, or should I say, we are not, familiar with technologies like decentralized finance, NFTs. decentralized autonomous organization, and decentralized applications. But with the coming of blockchain and smart contracts, we're able to identify that there are many ways we can actually use these technologies to our own advantage. Take for example now decentralized finance or non-fungible tokens, which are NFTs. Look at how it is rewarding creativity by just deploying or minting a particular form of art and then deploying it on a smart on a blockchain. It gives you power. You know who owns this what do you call it, those creative arts, and then you actually know at what price you've sold them. So these are things that we cannot use the traditional technology to do, because traditional technology is not meant for things like this. So with the coming of blockchain and smart contracts, we're able to identify that yes, we can actually have new ways to do things. Decentralized autonomous organization is a form of centralized system whereby people can just carry out, it's a form of governance whereby people come together and agree on a particular thing, and then that works for them. So these are not stuff that can actually work with traditional technology. We need something like blockchain technology and smart contracts, since it is self-executing, before we can enjoy such kind of novelty. So apart from enabling new technology, we have automating trust. Smart smart contracts remove middlemen and automate complex processes, building trust through codes, not third parties. For example, if you want to send let me just use money. If you want to send money from Nigerian banks to, and let me just within Nigerian banks, you find out that there are so many things that uh, are hindering the transaction to carry out to go to make it successful. We have network, we have this, we have that. The application is crashing and other things, thereby creating a form of doubt between the users. But with smart contracts, we find out that yes, it can remove middlemen and automate these processes. Because if you are sending, let me say, one Bitcoin, it is that exact same of the amount of Bitcoin that is going to the other place. It does not require somebody to help you calculate it or to help you see how it is going to pass through all this technology. No, it is already what? It is already self-executing. So when these conditions are already met, it directly goes to the other person, which I said earlier that it powers what? Peer-to-peer transactions. Also, smart contract is the backbone of Web3 because it enables what we call programmable internet. It makes the internet dynamic and responsive, allowing logic to be directly embedded into online interactions. So you are the one that will decide how you want to use the internet now. Unlike before, you feel people just steal your data anyhow and then you give out data anyhow. Now you have power and you have control over whatever you are using on the internet. And finally, we have peer-to-peer interaction. Peer-to-peer smart contracts facilitate direct interaction between users with rules enforced automatically by the blockchain. If you want to send 10 bitcoins today, you don't need anybody to help you calculate it. The blockchain you don't need anybody to exchange hard currency, or let me just say, yeah, hard currency. You need somebody to do the calculation, and then you want maybe the person will now try and see how he can facilitate it. No, in terms of smart contract, it is just automated. Anything you want to do is directly there. I want to send you a social amount of Bitcoin, it goes directly. You want to send me some amount of Bitcoin, it's going to come directly without anybody interfering with the transaction. So these are some of the reasons why smart contracts are the backbone of Web3. All right. So we have key features of smart contracts. So number one, it is trustless. It is trustless. No need for intermediaries. Trust is embedded in the code automatically because we said until a certain condition is met. If those conditions are not met, there is no way the transaction can be executed. Number two, it is immutable. Once deployed, code and transaction history cannot be altered. Someone will not go and delete the history of the transaction that has been carried out. There is no way that can happen. It is stable, it is there forever. So whenever someone said, I've done ABC on a particular blockchain, we can actually go and verify if it has happened or not. It is transparent. All contracts, logic, and operations are publicly verifiable and viewable. You can go and verify and view a particular what? A particular transaction or operation that has been carried out on a blockchain. So whatever it is that you have, or whatever it is that you are trying to carry out, if it is on a blockchain, you are rest assured that it is transparent. It is autonomous. This is self-explanatory. It is automatic. It executes automatically when conditions are met. It's also composable. We can interact with other smart contracts to build complex application. For example, decentralized finance is what? Is a complex application. Decentralized applications, many of them like games, are all what? Um, are all composable because they are all complex and composable because we interact them. So please, can I do you all understand what I'm saying, or the someone is confused somehow on the line on the way? Hello.
Yes, we can hear you. Guys, please, if you are confused, please.
You are confused?
No, no, I'm asking. If you're confused, please signify. No, I see your hand
Okay.
has been raised since. Can you unmute yourself and speak? Okay, seems like everybody's okay then.
All right. Thank you. Let's continue. So, benefits of smart contracts. Um, we have been talking about smart contract, the features, and the rest, how it works. So, it also have lots of benefits. Some of which includes lower costs, reduced reliance on intermediaries and manual processes. Because we don't have intermediaries now, the transaction is peer to peer. So, it's what it facilitates, or one of the benefits is what is lower cost. It's very low in terms of transaction. Faster transaction. Automated execution ensures quick and efficient agreement. So when we are using smart contracts, we are guaranteed of what? Faster transaction. Unlike our traditional technology, for example, I still want to use Nigerian banks. You can send money and it will before the recipient of that money receive the alert, it takes minutes or hours. But with smart contract, it's just a matter of seconds. Of the smart benefit of smart contracts. Automation. Smart contracts streamlines complex workflows, minimizing human errors and delays. So, with smart contracts, you know that the number of errors we are maybe going to encounter has been minimized or has been removed or eliminated, and the delays are also smart contracts are deployed on blockchains, and then blockchains have what we call cryptographic security, which reduces fraud and increases trust. So you might be hearing about everybody talking about what do you call it, security when it comes to blockchains. There are so many things involved. So this cryptographic security is a form of mathematical calculation that is carried out on the blockchain. So if it is not, if you don't have this cryptographic security, our blockchain are going to be what? Are going to be easily exploited and it is going to be exposed. But the people that have this intention of bringing the power of Web3 to everyone have thought about this before they actually made it available for everyone. There's no way you talk about providing something that is very useful or very complex as blockchain without thinking about security. Unlike our traditional technology, cryptographic security is one of the best security when it comes to encryption. So blockchain, or one of the benefits of smart contracts, is what is enhanced security. It's beyond what we use in our current traditional technology. Global accessibility. Everyone interacts with so many decentralized applications today. As a result of what? As a result of smart contracts. We can use different applications today from anywhere in the world. This gives everybody the ability to participate from anywhere you are in the world, whether it is commerce, whether it is finance, or any other thing. Smart contracts are what gives this power to people. And then transparency. I've talked about transparency many times. So let's move to the other slides. What do we talk about this? So we have use cases of smart contracts. Host, can you confirm that we are on the same slide?
No,
Is this use case?
we're still on why smart contracts is the backbone of Web3.
Okay, I
Okay.
think.
Yes,
What
we've
about
moved
now?
now. Yes.
Okay, so we have use cases of smart contracts. Number one is decentralized finance, automating lending, borrowing, staking, and yield farming with platforms like Uniswap, Aave, and Compound. There are so many decentralized finance applications out there. I've already talked about decentralized finance, but let me just brush through it again. So, in one of the use cases of smart contract is decentralized finance. What does it do? It gives you the ability to what? To lend, to borrow, and also to stake. It's what we call yield farming as well, which is part of decentralized finance, which platforms like Uniswap, facilitated, and then they bring it live to their users. There's also gaming. This allows users to truly own and trade in-games items with smart contracts managing assets and reward. So you can be playing games now, and then you find out that you are getting rewards by actually hitting a particular target. The moment you hit a particular target, you get rewarded. What is making that possible is what? Is smart contracts. Because it has been automated that the moment you actually hit this target, it should reward you with a particular token. So by you doing that, it is also managing your asset. So the moment you reach a particular level and you feel like you want to move now, it's that asset does not vanish. It's still there. And your rewards are what? Are still there as well. So what makes that possible is smart contracts. So we have NFTs. So non-fungible, they are not NFTs are non-fungible tokens. This smart contract also manages the minting, ownership, and royalty payment for unique digital assets in arts, music, and gaming. Non-fungible means it is not. We have different types of tokens. We have the fungible tokens and we have the non-fungible tokens. So fungible tokens are like the USDT, the cryptocurrency, and the rest because it is fungible because at any time you can actually convert it value for maybe cash or anything or maybe other items you want to get. But non-fungible tokens, these are form of tokens that you can they you have to lease it or you have to mint it, give it a particular form of value. When someone buys it, that's when you get a particular value out of it. For example, art. You can be a very creative, artist, but there is no way you can just put it out there and then you get money. You have to mint it. You have to wait for someone to buy it before you now get value out of what you've sold. Likewise in music and also gaming. So these are some of the smart use cases of smart contract. NFT is one of the most important use cases of smart contract. You have insurance, automating payout for specific events such as flight delay or whatever or external data automatically by actually reaching a particular milestone in insurance. I don't know how insurance work, but I know that you have to, hit a particular target before any insurance organization will have to come and, grant you whatever you are looking for from them. So we have decentralized autonomous organizations, enabling community governance through automated proposal, voting, and fund allocation processes. For example, now, in every tertiary institution, there's what we call, what do you call it? Student union government. So what student union government is, they have executives that actually come from different faculties or from different programs or from different courses and say, we are representing our people, isn't it? So what they're actually doing is they are representing you. So they don't actually know what form of um what you actually want at a particular time. But with decentralized autonomous organization, you can submit a proposal. Let me say Bayero University Kano now can submit a faculty in Bayero University Kano can submit, let me say faculty of environment or faculty of education can submit a proposal that we want new chairs in our theaters or we want air conditions in our theaters, or we want a particular form of tool that is going to help in learning in our theaters. Let me say projectors or smart boards. This is what smart contract is enabling. Unlike the normal governance we know, they will just go and sit and then decide whatever it is, whether it is of your favor or not, they've already decided. But with decentralized autonomous organization, you can actually be part of a particular governance. You can also voice your own opinion. You can decide this is what you want, this is how you want it, and then people will come and vote, and then it will be approved. This is how decentralized autonomous organization work. They enable governance, enable community governance through automated proposal. You come and submit proposals, you vote, and then if there's funding allocation, you get funding allocation for this kind of activities. And then finally, we have supply chain, tracking and verifying goods, triggering payment or alert upon delivery, milestone or quality checks. Now, times that number, our government will say there's distributed rice, they have distributed medicine, they have distributed mosquito net, they have distributed so many things. In the end, we will say we did not receive this. Why? Because somewhere in the supply chain, somebody is trying to be very greedy, or somebody is trying to hijack the whole thing. But with smart contracts, believe you me, it can be tracked from the beginning to the end of where this particular goods or product is. If you want to deliver drugs to people, what are the first points? And then it has a particular it signals that it is at this stage. You see it live on the blockchain that this is where it also see where it is till when it reaches the end. This is what, because it is on a because it is deployed on a blockchain, and it is designed using a smart contract. Every condition is actually met. We can now understand that yes, it is working because this is where it is. Now it has reached a particular location. Yes, the conditions are met. This is where it is. So governance or government can actually take advantage of this as well to ensure that when they want to distribute anything to the people and they want to show transparency, they can use this. But because government will always be government, there's no way they are going to use this because somebody will just come to the television and say they are going to do ABC, and everybody will be clapping, while truly in their heart they know that they are not going to do it. So smart contracts are helping us, in terms of supply chain. Another example of supply chain or the use of smart contracts for supply chain is when you want companies when they want to deliver any kind of products. For example, now Coca-Cola, if they want to deliver their product and ensure that it's in a particular location, they can use smart contracts for that. Don't forget, I say we can use it to track and verify goods. We can also use it to trigger payment or alert upon delivery. So if it is moving to a particular location, this can also be used, in fact, to combat fake products. Because it is coming from a particular company, you can use it to what? To track whenever these goods are being distributed. So it eliminates anything that has to do with what? With fake, anything that has to do with fake products. You understand? I think government needs to key into something like this, or anybody can develop a solution around this kind of use case, so that we can foster, the development together, not just relying on one side that government has to do it. Anybody can actually do this, and then see how we can enjoy this form of technology altogether. So smart contracts are actually, very, very important when it comes to what? When it comes to Web3. First of all, it powers decentralized finance. Secondly, it powers gaming. Thirdly, it powers creativity. We're using non-fungible tokens. Fourthly, we have insurance. We also have decentralized autonomous organization, which are known as DAOs. And also, finally, we have what we call supply chain. So these are some of the use cases of smart contracts. Is there anyone with a question?
You come to rent center. Mr. Mo,
Yeah, I can hear you.
Okay, you're done presenting.
Yeah, I'm done with the first part. I have another part I want to present. So I want to know if there's anyone with a question or not.
Okay, thank you very much. I can see some people's hands raised, so I'll start with Michael. Michael, make
Okay.
yourself and ask the question.
Okay, you said something about DAOs or what it means.
Okay. All right. Thank you very much for that question. This is a very good question. So if you look at what do you call it, blockchain communities, or you go to their governance. Michael, can you please mute your mic? Sorry. All right. So when you look at blockchain governance forums, we have different form of, or what do you call it, proposals on that forum. So now you can decide. For example, I'm just giving an example with students. We have SUG now, for example. SUG can just decide to have a form of platform where everybody can have their own opinion, or they submit a proposal on what they want to do. So by allowing everybody to come and submit the or showcase their own opinion, we are actually making it very transparent, and also ensuring that everyone is what is involved. If BUK student representative assembly can decide they want to dash everybody money today, and that is what the student want, it can be voted. Our hostels, we need electricity. In our hostels, we need so many amenities. You can just go there, and then you can voice your opinion out. People will come and vote for it, because there are other people on that forum. By voting, it shows that what people are, what are solar smart contract on a blockchain. There is no need for you to say, I've made a mistake, I want to go and change this. No, this is not the person that is supposed to use this. No. The moment it is being deployed on a blockchain, unless if you are going to pull it down and change it, there's nothing like, I want to edit again and then send it. No, it's not going to be like that. That's not how it is. That is only possible with traditional technologies, where you can have one or two mistakes, and then you can refactor the code, and then you can now have you can now what do you call it, you host it again. But in terms of smart contracts, the moment it is being deployed, so that's the end. You can only pull it down, or it will take long time before you can have or trace or audit those code and then change it. So also, very complex and that, because one thing about smart contracts, it is very complex to upgrade. It has complex upgrade mechanism. Updating smart contracts can be challenging due to their immutable nature, often requiring new deployment. Like I told you earlier, there is no way you say you want to deploy a smart contract on a blockchain and you feel like you made a mistake and you want to change it. It's not possible like that. The moment you deploy it, you have to what? If it contains so many bugs, you have to pull it down, and then you deploy a new one, because smart contract is just a set of rules and criteria, of which you are deploying it for people to use. So by creating those criteria and rules, you have to be very sure of what you are deploying to the blockchain. Nothing can be changed the moment it is being deployed on a blockchain. That's why we say one of the risks and challenges of smart contracts, it is that it is very complex to upgrade. You have to what? You have to take your time before what? It is very challenging because of the immutable nature of what? Of smart contracts. The moment it is there, nothing can be changed. You have to pull it down and then make those amendments. Then you now move what? You now deploy a new smart contract. Another challenge is what? Is high gas fees. Network congestions can lead to increased cost of deploying and interacting in contracts. One of the key trilemma, according to Vitalik Buterin, the CEO of Ethereum, he said one of the trilemmas of blockchain is it includes scalability, security, and what? And costs. Because as a, we are trying to deploy these contracts on the chain. The moment it is, there's congestion, there's going to be increased form of what? There's going to be increase in cost, thereby leading to high gas fees. So imagine on Ethereum now you want to mint a particular NFT. As a result of congestion and as a result of network congestion, what will it will lead to what? High cost, because it's going to prioritize a particular what? A particular smart contract over the other as a result of what? As a result of congestion. Now, another risk is what? Legal and regulatory uncertainty. The legal framework for smart contract is still evolving, causing challenges for enforcement and dispute resolution. Nigeria. In Nigeria, up to now, we are still trying to see how we can use what, how we can decentralize applications as what, as something that it is fully legal. They are still trying to see how they can use the Securities and Exchanges Commission to what, to ensure that whatever people use is something that is what, it is trustworthy and it is what, it is transparent. So that's why most countries have not finally, regulated or allow it to be a form of a legal entity for what? For smart contracts. Everybody's trying to provide a legal framework around it, whatever it is, and then everybody's yes, and the rest. But there are so many uncertainty around it. And then finally, we have scalability issues. Some blockchains are not scalable. Like I said, one of the trilemmas of blockchain is what? Is scalability. Blockchains can sometimes struggle with the volume of transaction, leading to slow processing. Example is Ethereum. Anyone that understands the Ethereum network knows that it is one of the slowest blockchains, or one of the slowest scale at once. Likewise, Bitcoin. The protocol that built Bitcoin is being deployed on is also very slow. That's why we have other blockchains that are trying to solve this issue of scalability. For example, we have Polkadot, we have Near, we have Solana, and the rest. Especially recently, we've seen tremendous success with Solana being one of the blockchains that is showing lots of progress when it comes to processing transactions. It is really one of the fastest blockchain. Any developer can actually, those that have interacted with it will tell you, because we've seen lots of and lots of transactions carried out, and then there's no slow processing, which is really tremendous. So these are some of the risks and challenges of smart contracts. Someone asked a question about this, about hacks earlier on the issue of smart contracts. There was a time we had, as a result of what? As a result of a bug. So if you are into web development, there's what we usually call, there's what we actually call a bug. So what is a bug? A bug is an error or flaw or fault in a program that causes it to produce incorrect or unexpected result. So if you actually have a smart contract that is having a form of flaw or is having a form of error or something that is faulty, and you deploy it on a particular blockchain, somebody is going to exploit that little flaw, and then thereby maybe hacking the entire blockchain, or maybe providing an unexpected result. So these are the things that we need to ensure that. That's why we have standards now when it comes to deploying smart contracts. Of there are standard rules that everybody has to follow, so that you deploy a very risk-free or bug-free smart contract on any blockchain. Every blockchain now is trying to see that whatever is being deployed on it is what is risk-free and it is bug-free, because they understand this kind of bugs. The moment it is being deployed, somebody can just disguise and then deploy a very faulty smart contract, thereby controlling the entire chain, which is very bad for anybody that is actually, ensuring that this blockchain is being run, or any network is being run by people. So whatever the case may be, there are standards that needs to be followed in terms of ensuring that these smart contracts are bugs and error free, so that whatever condition or criteria that is being initialized or is being expected is what is going to be achieved. So I think that is all for now. If there's any question, I would like to entertain them. Thank you.
Okay, thank you very much, Mr. Mo, for that wonderful presentation. This session was really, really, really insightful. So, before we go to the question part of our cohort, please, if you have any question, raise your hand. I'll start by reading Nimat's question from the comment section. And Mr. Mo, please, can you share your slides, the one you need for your presentation, so that we can have access to it and maybe go through it?
You say you want my what? My
Your
slides? Which
slide, yes.
aspect?
Yes, if you can just share it on the group after the call.
Yeah, sure, definitely. I'll send it.
Thank you very much. So,
Thank you.
in the comments, Nimat is asking, she says, due to its complex mechanism, is there a way the future of blockchain would impact or affect the smart contracts function?
I didn't get your question. Sorry.
Okay, I said Kokori Nimat from the comment section is asking that due to its complex mechanism, is there a way the future of blockchain would impact or affect the smart contracts function?
Okay. Due to its okay, I can see the question. Due to its complex mechanism, is
Yes.
there a way the future of blockchain will impact or affect the smart contract function? Definitely, this blockchain is the infrastructure that we deploy smart contracts on. So whatever the protocol that is being built around the infrastructure, definitely it will impact or affect how these smart contracts function. For example, now if you look at Bitcoin, Bitcoin has a particular protocol that it is following that it is following. So you can compare it to Ethereum. Ethereum deals with more of decentralized applications. So these things have their own form of rules that they build around. So it is definitely so Nimat, it is definitely going to affect or impact how smart contracts function. Thank you very much. I hope I've answered your question, sir.
Yes, thank you, sir.
You're welcome.
Thank you. Thank you very much, sir. So there's another question from Lois. She's asking about her question about cryptographic security.
Okay, yeah. Sorry, it skipped my mind, but let me just answer it immediately. So when it comes to cryptographic security, we are talking about the science of securing information using mathematical techniques, like I've said earlier. So whatever the case may be, cryptographic security has to do with some kind of mathematical calculations that is going on mechanism I was talking about, the protocols that we talk about. These are mathematical functions that goes beyond the scene. Let me just use that English that you cannot see. So these mathematical calculations ensure that there's confidentiality, integrity, and authenticity at the same time. Because if you build what do you call it? If you build a particular blockchain and it is exposed, nobody's going to use it because everybody is trying to ensure that my asset is being secure. So when you talk about confidentiality, for example, those mathematical calculations ensure that data are hidden from unauthorized users. For example, you can say encryption. So one of the cryptographic functions is what is encryption. So we talk about integrity as well. So this cryptographic, calculation or mathematical calculation ensure that there's what the data has not been altered, and this is where we use what we call hashes. So there are so many terminologies in this thing. I don't want to bore you with so much English that you get confused. So when it comes to authentication as well, we have what we call digital signatures. This is all form of what the cryptographic form of security that is carrying out that is being done beyond the scene. You cannot see this being done. That's why if your passphrase is not correct, there's no way you have access. If you forget it, the account is gone. You have to ensure that it is yours. You have to verify and provide all the necessary what do you call it form of security before you can actually own it. And then finally, we can also talk about what we call non-repudiation.